Hello everyone, it's good to be back and I will be discussing to you theorems about secants and tangents of circles. For our first topic, we will be discussing cases in which the secants can form angles in circles. So there will be three cases. The first case is when the vertex is inside the circle. So you have to observe that the secant line crossed or intersect inside the circle. The second case is when the two secants intersected, the vertex is on the circle. So when I say on the circle, the point of intersection is on. It is within the boundary of the circle. And for the case number 3, the vertex is outside the circle. So when you say that the vertex is outside the circle, the two secant line intersected outside the circle. So let us now consider an example. Let's say that the circle which is given, we are asked to find the measure of arc MR. So where is arc MR? So there is it. That is arc MR. The two secants intersect outside the circle. So this falls under case number 3. That is, we have to use the given formula for case number 3 to find MR. So since the two secants intersect outside the given circle, so we'll be using case number 3. So how do we solve? Just write the formula. Okay, just substitute the given, right? Substitute the given values for the arcs. Okay, so we have here, okay, the measure of angle Q is equal to the measure of AB minus the measure of arc MR. Alright? So, we will be considering this given. Okay? So, baka malito yung iba, no? So, we are talking about this circle. Right, so this is our angle Q. So, let us continue. 2 times the measure of angle Q is equal to the measure of AB minus the measure of arc MR. So, saan ang galing yung 2? Dito po siya. Okay, 2 times MQ. Then, substitute the given as reflected in our example or in the figure. Then, simplify. Therefore, the measure of angle Q, the measure of arc MR is equal to 60 degrees. Okay, I hope that's clear. That is very simple. Okay, to continue, let us consider the two circles. For circle Q, we are showing a secant line. So what is a secant line? And in the second figure, we are showing the tangent line. So as shown, madali naman siyang ma-identify, di ba? Ano daw yung secant line at ano yung tangent line? So nakita nyo ba yung pagkakaiba sa dalawang line na yan? Now, remember that the secant line is a secant of a circle is a line that intersects a circle at exactly 2 points. Okay? So, ang ating line AB ay nag-intersect sa ating circle Q at point A and point B. So, we have 2 points. So, kung titignan nyo yung tangent line, alam nyo na agad no, kung ano yung kanyang definition. So, it intersects the circle at exactly 1 point. So, point R lang pag tangent. Pag secant, 2 points. Pag tangent, ang tangent line natin na tinatawag din natin na point of tangency, itong point R is this figure or is expressed in that figure. So, an example of a tangent line is a satellite. A satellite moves. Yes, the satellite moves in outer space in a definite orbit. So, circular siya. Circular. Ito yung Earth. So, definite orbit, a circular, this path. The velocity of the satellite at a given time, which is the instantaneous velocity, is always in direction tangent to its orbit. So, in one point only. Okay? Now, for the following, we will study some properties associated with tangent line. Okay, so in the given figure, ray BG. So, where is ray BG? Okay, this is BG. Ray BG is tangent to circle Q. This is circle Q named at point Q at B. So, B here is our point of tangency. Find EG. Okay, so remember also that a tangent line to a circle is perpendicular to a radius at the point of tangency. So we also call that the tangent segment theorem. Okay, so again, by the tangent segment theorem that we will be using, you know that triangle QBG is a right triangle. So ang point B here, okay, the point of tangency, or we have the ray BG, okay, as one leg, BQ as another leg, and we have segment GQ as our hypotenuse. So we formed a right triangle. Thus triangle QBG is a right triangle. So we will be using the Pythagorean Theorem to find QG. So paano? Again, QG lang muna. Mamaya na talaga yung find EG. Because we have to find the length of QG first so that we can find segment, the length or the measure of the segment EG. Alright, so just apply the Pythagorean Theorem that we have discussed a while ago and in the other video. Remember that the Pythagorean Theorem states that the length of the hypotenuse, this one, the longest leg, the hypotenuse, which is always opposite the right angle. So, in this case, it is named as QG or segment QG is equal to the sum of the squares of the leg. So, substitute nyo lang po yung value. So, QB, so kahit QB or BQ, that is 6 squared. Square nyo po lagi. And then BG, where is BG? BG here is given as 8. So, 6 squared, that is 36, plus 8 squared, that is 64, is equal to 100. And the square root of 100 is equal to 10. So, meron na tayong QG. So, using now both QB and QE. Okay? Sundan nyo po sa sinasabi ko yung mga segment. Both QB and QE are radii. So, radii po sila. Plural po siya ng radius. So, radii. So, QB here is equal to 6. Since they are both radius, so if QB is 6, meaning to say QE is also 6. So, by the angle addition, by the segment addition postulate, QE plus EG is equal to QG. So, we can use this to solve for EG. Okay? So, using angle addition, segment addition, and then you just substitute the values, okay, as given. Therefore, EG here is equal to 4 units. So, in the given figure, remember that tangent segments that intersect outside a circle are congruent. So, how do we analyze this one? So, we have here segment AB. Okay, so we have segment AB and segment CB meet at point B. So look at these two segments. Okay, so these are the tangent segments that intersect outside a circle. So yung point B, nag-intersect kasi itong tangent segment na to, nag-intersect sila sa point B. Now, if we can imagine, paano sila naging tangent? Kasi nga po, itong AB, pag in-extend natin, pag naging line, itong line AB, it only intersect the circle at one point. So, tangent siya. Another here, a line CB is also a tangent line of circle Q. Why? Dahil nag-meet lang po sila sa one point of tangency. So, point E here is a point of tangency for AB. C here is a point of tangency for segment CB. But these tangent segments intersected outside. Sa labas po sila ng circle Q. Nag-intersect. And therefore, the tangent segments that intersect outside a circle are congruent. So we can conclude that segment AB is equal to segment CB or BC. So it's just the same. Kahit mabaliktad po yung letter. So may I remind our students that when you are watching this video, please do not click that fast forward button. Tapos ibabalik, ipa-fast forward. Kasi kung gagawin nyo po yun, mas hindi ninyo maiintindihan yung lesson. So imagine this is a math class, but I am trying to explain this with Tagalog, no? Para magkaintindihan tayo. So please bear and so that you can learn. Pandemic kasi ngayon, so hindi tayo makaka face to face. So be patient, no? Be patient enough. Okay? So let us continue. So in the given, a polygon seems circumscribed about a circle. No? Pag sinabing circumscribe, okay? So look at this figure. So, di ba? Pag ang polygon is circumscribed about a circle, nasa labas siya ng circle. Yung isa kasi nating example nung nakaraan is a polygon or a hexagon is inscribed. So, a polygon is inscribed, nasa loob. Dito naman, a polygon is circumscribed, nasa labas ng circle. I hope that's clear. So, about the circle, if, so, papatunayan natin mamaya, of its sides are tangent to the circle. So, pag sinabi nating tangent, so itong ating triangle, isa lang yung point of tangency ng kanyang lahat ng sides. Okay, so I hope that's clear. So, tangent to the circle ha, 1 point lang sa bawat side ng triangle ang dumaan sa ating circle. Alright, so, if given, if GE is equal to 20, so this one, and EN, this is EN, hanggang doon lang ha, huwag kayong pupunta sa F, dahil ang sabi dito, EN lang. So, E hanggang N lang, yun, hanggang doon lang, sa point of tangency ng N, ay 11. And MF, ito lang din ha, MF, M lang hanggang F, is equal to 7. So, you are asked to find the whole GF. Okay? So, let us try to analyze this problem about circle Q. Okay. So, again, we will be using the segment addition postulate. So, we have EG is equal to ER plus GR. So, remember class, the tangent segments that meet outside a circle are congruent. Yung diniscuss natin just a while ago. So, you have ER is equal to EN. So, nasan ba si ER? Diba? Ito yung diniscuss natin kanina, na drawing natin. So, ganito siya katulad. Magkaiba lang yung name ng letter. So, ER, kasi congruent sila, is congruent to EN. And EN here is 11. So, meaning to say, kung ano yung haba ni ER, ganun din yung haba ni EN. By the segment addition postulate, so, ER minus EG na siya. So, GR kasi. So, yung ER transpose na katabi ng EG. Okay? So, we have 20 minus 11 and therefore, our GR here is 9. So, bakit kumuha pa tayo ng GR, no? Bakit kinuha pa natin yung GR? Eh, ang problem naman natin is GF. No, tignan natin. Kasi nga, i-apply natin yung ating tangent segment that intersect outside a circle. Titignan nyo na yung GR at GM is another view for this one. So, magkatulad sila ng idea na i-apply nyo dito. So, kuha na natin na yung GR is 9. Okay? Ito G to R is 9. Kasi yung EG lahat, 20, buo yun. Okay? Buo kasi yun. So, GE is 20. Okay. So, we have here, now, ima-minus na, we have now, GR, tandaan ninyo, is equal to GM. And GR here, as we have solved, is 9. Okay? So, we have GM is equal to GR, meaning to say, if this GR is 9 units, therefore, GM is also 9 units. So, in-apply natin, no? In-apply pa rin natin kanina yung tangent segments that intersect outside the circle ay congruent, no? Remember that one. So, we are now looking for GF. GF is equal to GM plus FM, no? Lagi natin siyang ina-apply yung ating segment addition postulate. I-add mo lang siya. Diba? Ayan, GF is GM plus MF. Baka sabihin nyo, teacher, gusto ko po ng MF. Okay. So, you have GM plus MF is equal to the whole GF. So, substitute. What is the value for your GM as we have solved just a while ago? So, that is 9 plus FM is given as 7. So, 9 plus 7 is... Let us now study the power theorems. These are similar to the three cases that we have studied in the theorems about seconds of circles. However, the power theorem focus not on the angles and arcs but on the segment formed by the tangents and the seconds. So, generally, these are about lengths of the segments. So first, let us have the secant tangent theorem. So in the figure, if tangent EG, this is a tangent line EG, intersects with secant FG at point G, which is outside the circle, then the square of EG or EG squared is equal to FG times HG. So remember that formula. The two-chord theorem states that if two chords AD and BC intersect at M inside the circle, then AM, the measure of AM multiplied by the measure of MD, is equal to the length of segment BM multiplied to the length of MC. So again, remember this thought and this theorem in this formula. The 2-secant theorem. So 2-secant kasi tignan nyo yung segments, no? Bawat segment, KT, nag-intersect siya sa ating circle in 2 points. So that's secant. TL also intersected with at point R and point L. So if 2 seconds, KT and LT meet at point T outside the circle, then the length of TP here, TP times TK is equal to TR times TL. So it's a very simple formula and a simple thought, but we still have to study and analyze. Okay, so for an example, we are asked to find the value of x in circle Q. So I will not show you the process anymore in here, but do you recall what theorem do we have or can we apply in this problem? Okay, very good. So that figure is just the same with the 2-secant theorem figure that I have presented a while ago. So you have to use the formula and make that formula as a model for you to answer and to find the value of x in circle Q.